Well, I asked the question there, how smart were the theropods? So their portrayal in recent movies, in books and things, have them as highly intelligent, rivaling their human prey in those movies. Well, how smart were they really? We can't really measure that because we have bones. But what we can look at is the size of the brain relative to the size of the body. If you have a big, big brain and a small body, that means you're processing a lot of information for your particular body. Well, let's look at this in greater detail. Now, we have what's called the EQ, the encephalization quotient, which is the ratio of the mass of the brain to the mass of the body. And in general, this is a rough measure of intelligence. So you measure the mass of the brain, the mass of the body, and there it is. So just some modern examples. So for humans, the BP, the brain body percentage, is a number that a unitless number after you divide the 2 grams here as 2.1. An elephant, by contrast, an elephant is huge. It has a huge brain, but also has a huge body. And after you do the ratio, the division, it has a number, a value of 0.15. So you see a human here has a 14 times larger brain mass in proportion to its body size. And of course, humans are far more intelligent than elephants. All right. Now, can we do this with dinosaurs? We can't really. We have the bones, so we can do the brain volume, so we can measure the volume of the brain case. You just simply have to take a full skull, fill it with water or sand, and pour it out, and then you can get a guesstimate as to the mass of the brain. The mass of the body is the problem. We just have bones, but you've seen in previous slides in this lecture series that we have estimated the tonnage, the mass of the body, by fleshing out the bones. And so we have a new formula. Rather than BP, we have BV, sort of the brain volume ratio is the mass of the brain by this estimated mass of the body. If we do this for dinosaurs, T-Rex, so mass of the brain, mass of the body, notice this BV value, 0.000079. Now compare that to the human BP value, which was 2.1, the elephant value, which was 0.15, and even relative to the elephant, much, much smaller brain to body mass for this T-Rex, which was probably one of the brainiest of the dinosaurs. And then compare that as well, though, to Triceratops, where you have a BV value after you do this estimations, division, 0.000035. So even though by modern standards T-Rex was no brainiac, it certainly was far more intelligent, I'm putting that in quotes, than its most common prey item, the Triceratops. And I bet if you did this with other dinosaurs, like, well, think about Stegosaurus, these numbers would be pitifully small. How fast was T-Rex? A lot of times people ask that question, how fast could these things run? And sometimes people estimate huge speeds, 40 kilometers per hour. Well, if you look at the momentum and the mass, which is equal to the mass times the speed, here's our estimated mass of a T-Rex, 6 times 10 to the 3 kilograms, times that 40 kilometers per hour, and then this is a huge momentum. So 6.7 times 10 to the 4th kilograms per meter second. And then compare that to an Olympic hurdler, which has this much lower value. What's different here is the factor for the multiplying by the 10. If this animal were running at top speed, if it could do this 40 kilometers per hour, and we don't know that it could, just a trip, a fall, a running into a rock or a tree or some other animal would be absolutely catastrophic. And so what it's done is it's made us sort of reassess these things, that maybe these extremely large theropods probably were not very, very fast. They didn't have to be. They had to be fast enough to get that prey, but really they just relied upon brute force. Now, this would be a different case, a different story for things like the raptors, which were smaller and lighter built, and some of them very, very small. They probably were very, very fast. Interesting to think about.